Hello everyone, welcome back to the course. In this section, we will start building contracts on Ethereum's network and we will look into the latest security issues you have never dealt with. We will create a simple address book decentralized application. We will see the flow of how to create a decentralized application from scratch, and we will also compile the address book contract. Today in this video, we will be looking into the Solidity, how to create contracts using this language. First of all, what is this language? And how to solve the problems using the contract, putting the business models, rules and regulations into the contracts. Firstly, Solidity is a contract-oriented programming language. Just like Java, which is class or you say object-oriented programming language. In Java, you create classes and then you create instances of those classes, objects. You use those objects to invoke the functions, look into the variables and more. In Solidity, we have contracts. We create contracts, we use the interfaces, enum and more. Solidity is derived from JavaScript language. So if any of you are familiar with JavaScript, then it is quite easy to learn Solidity. The function syntaxes, how to create a contract, they all are same. It is the primary language to write smart contracts on Ethereum. What are smart contracts? Well, smart contracts are a set of rules which two or more parties can decide and fixate on. So in terms of real world, when we don't have smart contracts, both parties will just come under an agreement, they sign something and then just they approve with each other that these are the set of rules which we both will be following. In the same way, we can implement those kind of rules into the smart contracts. You use this set of rules for services, business model and many more. Let's look into the remix IDE first. Now, this is where we're going to actually code Solidity. I won't say this is the only place, but this is an IDE which is more famous and quite easy to write smart contracts, to compile them, and to deploy onto a test network or real Ethereum network also. It has many tools like debugging, testing. You can use the environment. If you want, you can use the injected Web3. If you don't know what is injected Web3 or what the Web3 even does, you don't have to worry about it. As we dive deep into decentralized applications and more, I'll explain what the Web3 will actually do. But first, this is where we're going to write our contract. We can create a contract, new contract here, like create a new file here, eth token.sol. Now bear this in mind that .sol is the extension of Solidity files, just like Java which has like .class and all. In Solidity we have .sol. To create a contract, just like in Java when we create a program, the first and foremost thing you have to do is create a class. Without creating a class, any program will not work. In the same way, in Solidity, while creating a contract, you have to actually create contract first and then implement or put whatever you want to do. But before that, in Solidity, we need to actually specify which version of the Solidity we will be using, like Pragma with the keyword Pragma, Solidity, then the version like 0.5.0 if you want to use that. And while creating a contract, you can use the keyword contract and the name of your contract like token, and that's the syntax of it. And one more interesting fact you have here in the remix IDE is that previously we weren't able to do this, but now you can actually select the compiler version. The latest compiler version right now I see we have is 0.5.4. One more thing you have to remember is Solidity is continuously evolving, so some of the features which you see quite commonly in other programming languages like creating array of string or anything like that, some of them won't work here still. Now it'll throw a warning or it'll throw an error stating that this feature is present only in experimental version. So if you want to use the experimental version of Solidity to use those features, you have to actually use Pragma, and there's a Solidity experimental version, so I guess it is ABI experimental v2, like that. All right, to give you an example, this is one contract which is hello world contract and it has a mapping So mapping is nothing but dictionary in Python, or you would say hash map in Java. It has key value pairs. I mean, like, you can point key to the value and you can return any value by using the key, which is an ID. And to create an array of string, we have to use bits 32, because array of strings is not a feature which you can actually create right now in Solidity. So string like this, public exit like this, and if I compile it, it'll actually throw an error stating that this is currently not present. Okay, this is an error which states that the compiler version which we are using is different than the version which we gave in the program. Alright, so anyways, this is what Solidity is in a nutshell. In Solidity, you can actually implement rules depending on the parties. For example, let's say voter. So this is a contract in which we actually store the votes and retrieve the votes of a particular person. So in this, we have a function which is valid candidate. In valid candidate, what we are doing here is that all the candidates which are present, we stored them in bytes 32 array. So in this candidates list, we have all the candidates which are actually participating in the election. Now what we are doing is we are asserting whether the candidate which particular person is actually voting is present in that list. This is a validation. This is actually a rule. In general, while an election is going on and it is not electronic, it's a ballot voting or like through papers, something like that. What happens is, like, you manually check the votes, you open the vote, you check whether this is a valid person voted, or while voting itself, they'll check you're voting to a particular candidate who is valid, and then they'll approve your vote. In the same way, we implemented that rule in the smart contract using the function valid candidate. This valid candidate will check, it'll assert that the candidate which is taken into this parameter of this function is actually present in the candidates list. And now the candidate list is something which we will give in the initial phase of the contract, or as soon as the contract is deployed. Like, these are the candidate lists. So in the contract, right below the constructor, just like in Java where we create constructor to have the variables which are by default should be present in the class, in the same way in Solidity contract also, what we are doing here is we're giving the list of candidates which are actually participating in the election, so that this will stand as the base to see this assert function. So this is one rule which we actually implemented in smart contract. In the same way, there are many rules which you can actually implement and make sure that two or many parties are actually following the rules, and it is done through automation using the software blockchain.